a huge thank you to Shaina for grooving me with me in the background of that music. It's always a great way to start the day. My name is Jesse, everyone. I know we've got a lot of familiar faces joining us for today's program, but if you are new to exploring by the seat of your pants, we are all about bringing conservation, adventure, and science into classrooms around the world. And if you are joining us this February, you may well know that the entire month we spend kicking out all the men and spending it celebrating the most amazing women in science and exploration from around the globe. It is typically our biggest month of the year. I think by the end of February, it's going to be 55 programs in 28 days, which is crazy. So if you're interested in cave divers and astronauts, zoologists, climate scientists, we have had it all this month. And I really hope you take the opportunity to check us out on YouTube or on our website with such great people. Now today too, we are joined for a special celebration. We have entered into a partnership with I Was a Kid. So this is a beautiful initiative by Karen Romano-Young to highlight through the power of art, creativity, all the diverse fields in STEM, and to make sure that kids like you, no matter where you're joining from, no matter what you look like, see yourselves as having a future in science careers. There are so many amazing jobs out there. There's so many amazing roles. And again, the world is your oyster. So today we are going to celebrate one of those amazing scientists who's joined in with the I Was a Kid program. I really encourage you guys to check out their website, their social media pages, and more. It's an awesome initiative, and we're so thrilled to partner with them. So our speaker today in that whole shebang is Science Shaina. Shaina Sadai. So she is in Holyoke, Massachusetts today, joining us from there, where she's going to talk about studying climate change and how it impacts the Antarctic ice sheet. So climate change, as you hopefully all well know, is one of the biggest challenges facing us as a species, facing us around the world right now. And what better place to understand its effects than one of the most untrammeled, unspoiled, most amazing, beautiful, remote places on this planet, which is Antarctica. So it's combining two of my very favorite passions here at Exploring by the Seat of Your Pants. And without further ado, I'm going to turn it over to Shaina to blow your mind over the next 20 minutes. And I can't wait for your questions at the end. Shaina, thank you so much for joining us today, and take us away.
Thank you so much. Hi, everyone. I'm really excited to be joining you. I am going to talk to you today about Antarctica and our changing climate. So first, a little bit about me. I was not always a climate scientist. I actually had a long journey to get here. I was many different kinds of scientists before this, and I started out with astronomy because I really, really love the stars. And growing up, I used to live in a place where I could see the stars any night, and I would go outside and I would just lay there and look up, and I thought the universe, it's so beautiful. And so that's what I did first. And then from there, I branched out. I went into physics and I studied astronomy from a different point of view. Then I went into math. I really like math. Math can be so fun and so useful. And then from there, I transitioned into thinking about our Earth. So I went from thinking about the stars to thinking about the Earth that I live on. And outside of school, I love the Earth in different ways. So I really like animals and nature. Here's a butterfly that I found in a parking lot, and I helped them find a flower. This is me bringing them over to the flower. This is my bunny rabbit, Ginger. We found her on the side of the road as well, and we took her in and we gave her a new home. And this is me canoeing into a beautiful bird sanctuary near my house. It's a nice way to get out and enjoy nature and see the beauty of our planet. And this is me with some of my friends that I do science with. I also really like to dance and to garden. So that's a little bit about who I am and what my background is. And I study Antarctica, but I don't ever actually go there. So Karen Young's project, I Was a Kid, she drew me in my work environment, which is my home office, sitting at my computer. You can see on my screen these little pink and purple windows that are open. That is computer code that I use to run Antarctic ice sheet models. And this is my inspiration, animals and flowers and this beautiful planet that we live on. And here's my map of Antarctica that I always refer to that when I'm doing my research. And so Karen captured all this really beautifully. Also the little dinosaur on my table and my globe, which you can see I've flipped upside down. So Antarctica's on the top. So I always remember what I'm thinking about. Usually Antarctica's on the bottom. And so this is my map. And this is me at my chair that she drew from a picture just like this. And so I never go there, but how do I actually study it if I don't ever go there? It's okay. There's many different ways to study science, and there's many different ways to study remote locations. If you don't go there, you can look at satellite data, or you can run computer simulations, which is what I do. And so I run many different kinds of simulations. Some of them are climate model simulations, like this one over here, where I can look at the whole world back in the past or forward in the future. And I look forward in the future. And so this is air temperatures, maybe sometime in the distant future. They look a little cold when we expect them to look hot. That's because this picture is showing us the difference in what it looks like if we think about Antarctica versus if we don't. Because currently our models don't really show Antarctica in the global climate. But if they do show it, things end up looking a little cold. And we can talk about that later. But it is still a warming world. This on this side is an ice sheet model. So we can run simulations of just the Antarctic ice sheet by itself to figure out how it might change as the global climate starts to change. And so as you know, we are in a changing climate and the Earth is getting really hot. This is happening because we have these greenhouse gas emissions that are raising our levels of carbon dioxide, methane, nitrous oxide, and other gases in the atmosphere. And as you're probably aware, these gases trap heat, which cause the temperature to get hotter. So you can see here that the temperature rise coincides with the rise of carbon dioxide in the atmosphere, and that from the 1880s to the present day, these have been going steadily upwards. So as this temperature starts to increase, these numbers, they're just thinking about the temperature in the air. So what we feel when we walk outside, averaged over time. And currently, the temperature has risen about 1 degree Celsius since the 1800s. 1 degree Celsius doesn't sound like a lot, but it actually is a substantial amount of warming, especially to happen in so short of a time. And so where does this warming go? That 1 degree Celsius that's happened, that's just the atmospheric component. That's just this little blue dot right here. But if we think about the total warming that has happened, the vast majority of it is actually going into the ocean. So that 1 degree Celsius that we think about, that's a small drop in the bucket of the overall warming that the Earth is experiencing. With most of it going into the ocean, we need to think about what's in contact with the ocean and who lives in the ocean. How does this affect fish? How does this affect whales? And how does this affect ice sheets that are in contact with that warming water? And of course, the warming is some of it is going directly into the ice itself, and some of it is warming up the land. And so thinking about Antarctica, it's at the bottom of the planet. So way down at the South Pole. And who lives there? The penguins. Also around the ocean in Antarctica, there's whales, there's seals, there are birds that fly down here, there are little krill, little animals in the ocean. And so there's lots of life there for being such a remote and extreme location. It's very, very cold. It's basically always winter, even though there is technically a summer, but it always feels like winter. And so Antarctica is important for all of the life that lives there, but it's also important for all of us over the rest of the planet. And so thinking about the Antarctic ice sheet, it's like a big, giant, truly giant chunk of ice. And it's sitting on top of the Earth's surface. It's sitting on top of bedrock, like the rocks outside. And so if we removed that ice sheet, if we just took away the ice sheet and we saw what it looked like underneath, it looks something like this. But if we look at the difference between these two things, where that bedrock is and where that ice sheet sits on top of it, a lot of it is actually below sea level, which is weird to think about. If we go back to this picture, some of these locations, where they actually come into contact with the Earth is below sea level. And there's just so much ice built up that that ice makes it above the level of the water. And so all of these places, this red line is showing you where that giant chunk of ice is sitting. And if you removed it, these are the places that would be underwater, and these greenish places are the places that would still be above the water. So that means that over all of these edges, where that ice is grounded below sea level, it's in contact with that warming ocean. And so if the ocean is heating up, if the ocean is taking in more than 90% of the temperature rise that's occurred on Earth, then that means that the ice sheet is a little bit vulnerable at those edges to that warming water. And so what happens is different places on the ice sheet are more vulnerable than others. The places that are below sea level are the most vulnerable of all, and the places that are above sea level are a little bit safer. And so we want to know, as climate scientists and sea level scientists, what might happen if greenhouse gases increase, if we have more carbon dioxide in the atmosphere, if the temperature goes higher. How will the ice sheet respond to that? Will the ice sheet melt? Will it stay stable? How much will it melt? When will it melt? All of these things are really important for thinking about the impact that Antarctica has on the rest of the world. And so in this picture, we're looking at NASA data from a satellite that's looking at Antarctica and thinking about, where is Antarctica changing the most? The places that it's changing the most are all these places that you can see in purple and red. That is where it's getting thinner. The ice sheet is shrinking. And the places in blue, the ice sheet is getting a little bit thicker. That's usually because there's a lot of snow, and a lot of snow can make the ice sheet thicker, whereas the warm ocean can make the ice sheet thinner. Usually it's the ocean warming that melts Antarctica rather than the air warming. And that's because down at the South Pole, it's still just really, really cold. And so it's too cold for the surface of the ice sheet to really melt very much. Only the parts in contact with the ocean are the parts that are really starting to change. And so if we look at how that happens, this is that bedrock I was talking about before. And this is the ice sheet that's sitting on top of it. Where they come into contact, we call this the grounding line. That's where that ice is grounded and stabilized on the rocks below it. And this is what we call an ice shelf. It's part of the Antarctic ice sheet that extends out over the water and floats on top of the water. And this is our ocean. This red part is water that's starting to warm up. And as it starts to warm up, it can go under the ice sheet and start to melt at this area. When that happens, where this line is can start to move backwards. But as you can see, this bedrock slopes down as it goes inside towards the middle of the continent. And so that means that this part is not very stable. It would be more stable if the bedrock went up, because it would be harder for the water to get in there. So any place like this, where there's a floating extension of the ice sheet, that's where we think that the continent is most vulnerable, and that's where we would like to see it protected. So what happens when the ice sheet begins to melt? If it melts and that ice that's above the water line currently, up here, goes into the water, then that raises the level of the water. It raises sea level. And so sea level rise, if Antarctica, if that whole enormous block of ice were to completely melt, sea levels would raise by almost 200 feet, which is a lot. But don't worry, that's not going to happen. But it could raise by maybe 1 feet or maybe 2 feet. And so sea levels, the Antarctic melt has currently contributed about 0.3 inches. So less than an inch is how much Antarctica has raised global sea level by since the 1990s. So less than a half an inch is not very much, but over time it could add up. And if we think about all of the things that contribute to sea level rise, there's not just Antarctica, there's Greenland, there's also the warming of the water itself causes the water to expand and take up more space, and that can raise sea levels too. So there's lots of different things to consider when we're talking about sea level. And this is just some images that Climate Central made showing one particular location, the Santa Monica Pier in California, at present day at a temperature rise of 1.5 degrees Celsius or at a temperature rise of 3 degrees Celsius. And so you can see that as sea level changes, the way that our cities are at the coast are going to change a lot. So in the present day, there's this nice beach, there's this pier, there's some games, a Ferris wheel up here. At 1.5 degrees Celsius, that water's really taken away the beach. And at 3 degrees Celsius, there's probably a lot of flooding happening here. So we don't want that to happen. We want to stop the raise of the temperature rise and keep the sea levels stable. But sea level rise, so the ocean, it's not like a bathtub. You know, when you fill up your bathtub and the line of the water, it raises at the same level everywhere in the bathtub. The ocean's not like a bathtub. The water level actually raises different amounts at different locations, which is kind of weird to think about. But if we look at how it raises in different spots, we call this a fingerprint. It's the fingerprint of one of those things that affects sea levels. So if we look at a fingerprint of Antarctica, as Antarctica starts to melt, the places that are dark blue here actually get more Antarctic melt. Now, this is really weird, right? Because Antarctica is down here. And so if it's melting down at the bottom of the world, then you'd think the sea levels would rise very close to the ice sheet, right? Because that's where the water is going in. But actually, that's not what happens. It actually the water rises higher, farther away from the ice sheet. And this is because of our friend gravity. So the ice sheet, right? It's a really big chunk of ice. And so it's got a lot of mass. And so it has a lot of gravitational pull. And that big ice sheet is actually pulling the ocean towards itself. But as it starts to melt, it's not as big of a mass, and it doesn't have as much of a gravitational tug on the ocean. And so the ocean, in response, moves away a little bit as it starts to melt. And that's why you get higher sea level rise farther away from the ice sheet, especially in the middle of the ocean basins, like in the Indian Ocean, in the Pacific Ocean, and in the North Atlantic. This pink line is where we have average. Everywhere below that, lower than average. Everywhere above that, higher than average. And I know I've plotted the Earth a little bit weird here. I did it on purpose. I plotted it this way because I wanted to show the locations of places that we don't usually think about. And I know some of you are joining from Hawaii, so I don't think you usually see yourselves in the center of a map, but here you are right in the middle. And so this was to show that if we think about centering our oceans, then we can project the Earth in any way we want. And this is just a projection that shows the oceans as being central to our planet. Okay, so sea level rise, they're changing, it's going up, it's increasing over time, and it is spatially variable, meaning it's going to happen differently at any different place. And so really, we don't want sea levels to rise. We don't want the temperature to rise. We want our planet to be very stable and very healthy so that everyone on it is safe. And so we want to work towards climate justice. And these are a bunch of kids that I had the opportunity to work with. This is at the Western Massachusetts Youth Climate Summit. And so this was a summit where kids got together and they learned about the changing planet, and they came up with action plans to implement at their schools to try to help stop climate change and work towards a better future. Because ultimately, that's what we all want, is a better future for everybody. So that means reducing those greenhouse gas emissions, stabilizing the Antarctic ice sheet, and preventing the sea levels from rising too high. Thank you so much, and I will look forward to your questions.
Fantastic. Shaina, what a rapid fire tour of so many neat things. And I love the sort of crazy map views. I've always liked when people take the opportunity to not just show the Earth as sort of we always classically see it. Antarctica on top in particular has always been a fun thing. A lot of our Antarctic researchers have done just that. If you want to exit screen share, you can see us again, have a bit of a conversation. That would be awesome. A quick hello to Karen Young, too, joining us on YouTube today. Welcome into our second star of the show. In live classes, we're going to head to you guys. If there are YouTube classes, feel free to share questions in the chat, or we'd love to hear from you guys. But what we're going to do is first go to Miss Pierce's class, one of our 3 groups today in Baldwinsville, New York at Pearl Palmer Elementary. Miss Pierce, come on in and take us away with a question. Hey, guys.
Can I do it? Hi.
Oh,
Hi. If we don't stop global warming, how long will it take for Antarctica to melt?
yeah. Did you catch that, Jada?
How long will it take for Antarctica to melt?
If we don't stop global warming, like if we just let business as usual, do we have an assessment or idea of that?
If we don't stop global warming and we stay exactly on the trajectory we're on now, then the sea levels could rise a couple feet by the end of the century and more thereafter. Because once Antarctica starts to collapse, parts of it just keep on going. And so it's probably going to play out over hundreds of years, the full extent. It'll take hundreds of years to see what the ice sheet actually does. And then those water levels will stay higher for thousands of years. So we're talking really, really far in the future. But probably the whole thing won't melt.
Fingers crossed. And I mean,
fingers crossed.
Yeah. I mean, this is one of those things that's really important to note about climate change. And I like that you highlighted this 1 degree rise. Like, so much of climate change sounds so minor. Oh, it's 1 degree, it's 1.5 degrees. Oh, it's warmer, that's better. What we're seeing, and certainly the kids in this generation have lived their whole life with, is that can lead to so many variables that are out of our control, and so many extreme weather events and changes that are weird and strange. I mean, when I was a kid, winter was quite different than it is now. And that's in 20 years. I mean, winter used to be pretty consistent all the time. And now it's like, is there going to be a winter? Is there going to be 10 feet of snow? We don't know. It's it keeps it interesting in not the best way. So I'm glad we got that question to kick us off. Miss Stack's class, come on in, you guys. Again, our same school, Pearl Palmer, welcome in, guys.
Stand here so they can see you. There you go.
In Antarctica, can the animals change their behavior from global warming?
Great question.
Whoa, can the animals change their behavior from global warming? Yes, they actually can. Animals like to live under certain conditions. And so if the conditions in one place start to change, they sort of move around a little bit until they can find the conditions that they're comfortable in. The difficulty for a lot of animals is, especially for the penguins, if the parts that they want to, penguins like to lay their eggs a little bit near to the coast so that the parents can go get some fish to eat. And so when the ice sheet starts to change at the edges, it can really affect where the penguins want to put their penguin colonies. And so, yeah, they do actually move in response to changes, and they do try to find places that are suitable for them.
One of the things that we talk about in climate change presentations a lot is that, animal species can adapt. They can certainly adapt to things. One of the things that makes this a really unique element of climate change, or time of climate change, is how fast it's happening. So in the past, whereas climate change would happen over hundreds of thousands, millions of years, here it's happening in 100, 200 years. And so it's very difficult to evolve those new habits to adapt to those changing conditions that rapidly. That's where we're seeing some real impacts of climate change on a lot of wildlife populations. But I love that question. Way to go, Miss Stack's class. Miss Cottrell's class, come on in as well. And you can highlight the thing you said in the chat as well, because I love that. Hey, Miss Cottrell's group.
How is Antarctica similar and different from the Arctic?
Oh, that's such a good question. How is Antarctica different from the Arctic? So they're actually totally different. The Arctic, if you think about the Arctic up there at the North Pole, it's a lot of water with sea ice floating on top of it. And then around, so that's what's in the middle, a lot of water with sea ice floating on top of it. And then around the edges of that are the top of the continents. So like the top of Canada, the top of Russia, Greenland's off to the side a little bit, slightly down from the middle of the Arctic Circle. So water with ice floating on it. Whereas in Antarctica at the South Pole, it's a continent. It's actually a landmass. And there's just a giant chunk of ice on that landmass. And so there is ice floating on the water around the continent, but the center over the South Pole is a continent, whereas in the Arctic, over the North Pole, it's water with ice floating on it. And so because at the North Pole in the Arctic, there are continents all around the edge of the Arctic Ocean, that means that there's no water flowing in a circle around it. Whereas at the South Pole with Antarctica, around that continent, there's not other continents that are very close to it. So the ocean, it's actually very unique because it's the only part on Earth where the ocean around Antarctica extends the whole way around the globe. It's the only place on Earth that happens, where the ocean is continuous all around the entire globe. So there's a lot of differences in the way the ocean water moves, and there's differences in how the ice is set up. And there's also differences in why they're both changing. So in the Arctic, with all of that ice that's floating on top of the water, that ice is also starting to melt. And as that ice melts, it exposes that water that's below it. But the ice is really bright white, and so it reflects sunlight back to space. But once you lose the ice and you just have the water is very dark, which means it can absorb light. And so as the sea ice in the Arctic is getting lost, it's actually heating up faster, and it's undergoing what we call Arctic amplification, which means that the temperature there is rising really, really fast. It's actually the fastest warming place on the entire planet because of the way it's ice floating on top of water. And at the South Pole, because it's a continent with floating ice around the edges of the continent, it's staying a little bit cooler because you don't have that situation where the ice melt is exposing a big section of ocean, which could take in heat. And so it's staying a lot colder in the South Pole than it is in the North Pole. And in my climate model simulations, I actually find that as the temperature goes up, at the South Pole around Antarctica, that floating ice around the edges actually starts to expand, which means it's sort of the opposite of what's happening in the Arctic. If that sea ice that's floating on the water expands, it can bounce back some of the sun's light, which means it can actually delay the amount of warming that we have globally, which is really complicated and weird, very counterintuitive, but it's something that the models show.
That was a fantastically descriptive explanation of Arctic versus Antarctica. We get that question a lot. That was awesome.
Thanks.
By the way, for what it's worth, I know we're biased because we're here together with an Antarctic researcher, but I'm totally team Antarctica. I live closer to the Arctic. Antarctica's cooler, I gotta say, perhaps literally as well as figuratively. But I encourage, talking about that current, just for a sense of place, I encourage all our classes when they're done this broadcast, look up the Drake Passage. So this is how when people go to Antarctica as tourists, they go on this channel from the bottom of South America to Antarctica. And because you have this current that goes right around the world, you get some of the most epic, basically, waves and storms on this planet. It's quite the journey. We've had people that have taken the Drake Passage before, and they live to tell the tale.
I have friends who've been there, and they took videos standing on the edge of the ship, and it's just bouncing everywhere.
Yeah, we had a scientist on recently. He talked about the fact that there's a scale for like how bad weather can get on the ocean. It's called the Beaufort scale. And so like 0 is like dead calm, and 12 is a hurricane. On his way there, it was an 11, and on the way back, it was a 9. So pretty, yes, it's Turner stuff. You take a lot of stomach medication when you take the Drake Passage. Let's head to Mr. Wheeler's class joining us in Ottawa, and then we're getting tons of questions on YouTube, which is awesome too. So Mr. Wheeler, come on in.
Okay, thank you. And we're a virtual class, so students are in their homes, and I'm in my home here just outside of Ottawa. I had a question posted from one of our students, Ariana. When did climate change start?
When did climate change start? That's a good question. It really started closer to like the mid 1700s, around the time of the Industrial Revolution, or that's when the atmospheric CO2 concentrations really started to rise. But some of the climate change is, of course, driven by humans, and it's driven by some humans more than others. And so there are social and political aspects of climate change that started a bit before that. But the rise of carbon dioxide in the atmosphere and the start of the warming really started to happen around 1750, so hundreds of years ago. And then it started to ramp up in the late 1800s, and then it really just took off from there.
Burning, I mean, the thing that a lot of our classes, of course, will know, we're burning fossil fuels, right? And this is something where we found this basically at that time conceivably inexhaustible energy source that was so exciting. And frankly, the fact that we're able to have a conversation on computers from around the world together is a direct result of that effort to provide that much energy to people. We're only really realizing in the last few decades, a little bit before your lifetime for our students today, that there's a lot of negative impacts associated with that. And that's why there's such a huge shift right now to switch to things like solar and wind and other power sources that are renewable and stuff that don't put carbon dioxide into the atmosphere. So we see this really concrete, long since proved trend of global warming caused by human activities. And I'm really glad we got that question. So thanks, Mr. Wheeler. All right, YouTube classes. There's so many of you. This is great. Josiah in Miss Johnson's class, they want to know, what is the average temperature in Antarctica?
The average temperature in Antarctica, it's actually different at different parts of the continent. But at the interior of the continent, like in the middle of it near the South Pole, is very, very cold. It's like minus 60 degrees Celsius. And at the edges, it's like at the edge of the continent, it's more like minus 10 degrees Celsius. And so it's very cold.
I take the feeling from the way you're saying that it's a little too cold for you.
It's too cold for me.
Rushing to Antarctica anytime soon. But I think a lot of our class today, certainly our New Yorkers, our Ottawa class today live, you guys are well familiar with minus 10 degrees. In fact, in Ottawa, you're used to minus 40 degrees because Ottawa is like the coldest place in Canada as a former Torontonian. Let's head to Ms. Robinson's class. They're on YouTube as well, joining us. Levi wants to know how big Antarctica is.
Oh, how big is it? It's almost as big as the United States, I think, if you compare it to something. I think I've seen pictures of the continent sort of laid over other places that have shown it to be about, it's like bigger than the size of the United States. I probably should have put a picture in there, but yeah.
No, that's totally fine. I just found one actually. It's one of those like great Googleable questions on the fly. So it's the US and Mexico combined. So there you go. Yeah, you found the same picture I did. So it's huge. And you never get that sense because in most globes or maps, you see this like little band along the bottom. You're like, oh, okay, right? It's gigantic. And so we've had people on before that like skied across Antarctica. That's quite the epic journey. That's many, many months in the happening. Great question, Levi. All right, we're going to go back to our live classes. We'll take a few more from YouTube. Shaina, we are whipping through these. We're only at the 30-minute mark. This is crazy. So Ms. Pierce's class, come on back in and take us away. Hey, guys. Hi. You have a second question for us?
Yes, we do. Clayton, go ahead. How much is the Great Barrier Reef being affected?
Ooh, the Great Barrier Reef. Is it being affected by sea level rise or?
That's a good question. Is the Great Barrier Reef being affected by sea level rise? Well, I think it would, because reefs like to be at a certain depth. And so if the reef gets too far under the water, then that's not very healthy for it. But usually the things that coral reefs are most affected by are ocean acidification, which is caused by the CO2, the carbon dioxide emissions getting into the water, and also by pollution. So like runoff from factories that's entering into the water and things of that nature.
I just brought it up on the screen. I'm so glad you mentioned that. So that's one of the things you mentioned, that a lot of the CO2 is being absorbed by the ocean. And that makes the ocean literally fizzy. Like just like your pop has carbon in it, that's what it does to the ocean. Not quite that extreme, hopefully, for quite some time or ever. But it really does impact coral in a negative way. We've actually featured a lot of coral programs in the past talking about how that causes coral to basically die. I mean, more so than that will happen a lot faster than there'll be an impact of sea level rise when it comes to reefs. But I love where your thoughts at, guys. Miss Stack's class, come on back in. And hey, guys.
How long will it take for waters to rise 1 foot?
Yeah.
Oh, yeah. That's a good question. How long will it take for waters to rise 1 foot? My guess is that it could happen by the end of the century. So maybe like 80 years.
You were so fast with that. I was pulling up stuff as you were talking. I need to get back. There we go. And it's like, it seems so far off for students in classes. You're like 80 years, like, wow, that's, this is something that is going to impact a lot of cities around the globe. And I mean, if you're in a place like the sort of central part of North America, if you're in somewhere like Toronto, Ottawa, even internal New York, like 1 foot level sea rise is not going to affect you personally. But for coastal cities, of which, of course, Canada alone, we've got Halifax, we've got Vancouver. In the US, we've got New York, Miami, San Diego, right, et cetera, et cetera. This is going to be something that impacts them in a really big way. And so it's going to take a lot of collective effort around the globe to make sure that a 1 foot level of sea rise doesn't cause millions of people to have to leave, and it probably will, frankly. So it's a huge challenge for humanity. It's something that I think is kind of exciting in the sense that it's something that we really can collectively tackle together, and that we all have a vested interest in making sure that we do the best possible things to prevent it. New York City alone has some fantastic ways of preventing water from getting into it. London, England, certainly the Netherlands, a lot of countries in Eastern and Western Europe already have these measures in place to prevent being flooded by sea level rise, and we're going to need to see more of those around the globe if we're to protect some of these, homes for millions and millions of people. Great question, guys. Miss Cottrell's class, and I did want to note just from the chat, Shaina, so they are the penguins in Pearl Palmer Elementary, and they love your blouse. So
Thank you so much. I buy all my clothing used, so I don't use too many resources, and I found it at the thrift shop.
Way to go. How fitting is that? That's awesome. Miss Cottrell's class, come on in.
Don't overdo it. Don't overdo it.
Why is Antarctica considered a desert?
Ooh, good question.
Oh, yeah, it's a good question. Why is it considered a desert? It's weird to think that it's a desert, but it is. It's because it's not, there's not a lot of precipitation that's happening there. It certainly doesn't rain, and it snows, but it only snows in some locations. And so it's very, very dry. And so it's dry like a desert, but not like a sand desert, like a snow desert, which is weird.
It is weird. I'm so glad that's the first time we've ever got a desert question about Antarctica. That's awesome. I want to stress for our classes, and shameless plug here, because it's super, super nerdy, McMurdo Dry Valley. So this is a part of Antarctica that is extremely dry, like level of like some of the most dry deserts on this planet. And if you go to the McMurdo Dry Valleys, in these places with 100-kilometer winds constantly, it's -40, it never rains, and you crack open rocks, you'll find lichen inside. You'll find living things in this most inhospitable environment on the planet, and I've always loved that about Antarctica. It's such a special and magical place. You might have to brave the cold one day, Shaina. I mean, it sounds really good.
We'll see.
Cross that fake pass and see what happens. We'll talk on that journey too. Mr. Wheeler's class, we'll come to you guys. We'll take a few more from YouTube, and then time flies and you're having fun. We'll wrap up after that. So, Mr. Wheeler.
Yes, thank you. Questions about drinking water in Antarctica. Is there fresh water? What would animals drink? What do humans drink when we're visiting scientists down there?
That's a really good question. I'm not entirely sure because I've never gone there or gone through that process. There could be like perhaps desalination, or maybe the water's brought with them, but I've never been there, so I'm not entirely sure.
This is like truly, Shaina, like I've done a lot of Antarctic programs. We've had some of the best questions we've ever had today, both on climate and on the location. I don't know personally. I'm trying to think back to some of the people that have gone expeditioning there. I mean, the ice itself is fresh water if you melt it, which would presumably be cheaper than flying in the water because it's absurdly expensive to get things to Antarctica. But that's a really good query. So animals would certainly drink from snow melt. They would get their water from food. A lot of animals get their water from food. Just something like penguins might get that from the fish that they eat. But I don't know that offhand either. What a cool question, guys.
That's a really good question.
Yeah,
if you find out, let us know.
Let's take a couple more from YouTube, and then we'll make sure you guys have the resources to keep the learning going. Let's see. Braden in Miss Johnson's class wants to know, how can we stop this from happening? I know this is a big part of what you like to emphasize in your outreach program, so do tell.
How can we stop this from happening? Well, there's two ways that we think about dealing with climate change. One is called mitigation, and the other one is called adaptation. So mitigation means to try to prevent the worst effects from occurring. And to try to prevent things from occurring, we have to get the carbon dioxide emissions to go down. We have to get the methane emissions to go down. All of the greenhouse gas emissions have to go down. And that can be done in different ways. Certainly, we have to stop using fossil fuels to, produce our electricity, to put gasoline in our cars. We need to move more towards clean energy and clean transportation. We need to expand options for public transportation. So fossil fuels are the biggest part of it, and transitioning away from fossil fuels and towards renewable energy. Another part of it is that actually agriculture and the production of food is a huge emitter of greenhouse gases, and mostly this happens because of animal-based agriculture. So the farming of cows actually produces a lot of emissions. So eating more plant-based foods is a big way to help reduce emissions as well. So yeah, reducing fossil fuels, reducing animal-based agriculture, and then the adaptation part, when you're trying to, you can't stop everything. Right. So you mitigate to minimize the amount of damage, and then you adapt to the parts you can't mitigate. And that can be done in lots of different ways. Some places will build a big seawall to make sure that the flooding stops at the wall. Some places are looking more towards restoring natural ecosystems at the edge of the water line, because a natural ecosystem like a mangrove swamp that can sort of buffer the effects of sea level rise and protect the houses more towards the inland. So restoring our coastlines is really beneficial for adaptation. And there's lots of different ways. The best way to adapt in any given place will really depend on the place itself. So every community that's a coastal community has to decide this for themselves. And one thing that I think is really important is not just to think about protecting the infrastructure, the houses, the people. That's extremely important, but we also have to think about how animals use space. So you wouldn't want to necessarily put a seawall on a beach where a sea turtle wants to go up and nest and lay their eggs. You want to think about everyone's use of space, how humans are using the space, how animals are using the space, and then pick your adaptation measure to be something that'll be beneficial for all.
Yep. Shaina, that was a beautiful and poetic answer. I love that. I love that you mentioned agriculture as well. It's something that a lot of people don't think about. For individuals in your classroom today, one of the biggest impacts you can do to help prevent climate change is to cut down your intake of meat. You don't need to go to zero. If you happen to be vegetarian or vegan, fantastic. That's a choice that actually does really help the planet. But for me, I live with a vegetarian. My meat intake's gone down radically since that's been the case. And so that really does go a long way. One thing that I really like to highlight to classes is that no individual can stop climate change. It can seem really daunting to think about this worldwide global issue with so many potential bad things and think, oh, it's up to me to stop it. No, your generation, though, is amazing. You guys know more than any generation before you. You are mobilized. There's groups of 500,000 youth around the world that gather to talk about this because you know the science and you know how important this is in a way that even our generation didn't really take up as well as you guys do. So you kids are absolutely doing an amazing job. A fantastic resource for your teachers for all our classes today that I'd encourage you to check out. I'll put up the websites for them. 2 books as well. So Drawdown, and that's how I lift it up, and Regeneration. Same author, collections of scientists around the globe working to figure out the ways to make sure that we mitigate climate change, working to figure out how we can adapt to it, and working to figure out ways that we can do that in a holistic way that helps healthcare, helps women's education, helps restore ecosystems, and so much more. So the best possible resources I've ever seen on that are below, and I encourage everybody to check those out. Shaina, what a great answer. That was awesome. All right. One more question. I'm so glad we got that one from Braden, so thank you so much. Let's see. From Spencer. So this is an Arctic question, but I like to throw it in anyway because we inevitably get a question about this animal in Antarctica, and we inevitably get penguins, and we're talking about the Arctic. So how are changes affecting polar bear behavior? Do you know offhand?
How are changes in Antarctica affecting polar bear behavior? Well, it's a little bit complicated because the polar bears are at the North Pole and Antarctica is at the South Pole. But actually, because the ocean connects all parts of the planets together, the water that's circulating around Antarctica takes hundreds of years and it travels up to the North Pole and it travels back down, and so the water in the planet is always connecting different places. And as the circulation of the ocean starts to change around Antarctica, it can actually affect the circulation of the ocean in the Arctic, which can in some cases help preserve the sea ice and help prevent it from being lost just a little bit. This is something that my models have shown, that as Antarctica collapses, it might actually delay when we lose the sea ice completely in the Arctic. But we don't want to obviously rely on that. We want to preserve the sea ice in the Arctic while also preserving the stability of Antarctica. So yeah, polar bears like to eat on the sea ice, so they want the sea ice to stay.
I like the description of some very complicated science. That was well done. I think a great useful mnemonic for our classes today. So the Arctic is literally named after the fact that it has bears there. So Arctos is bear, Arctic, there are bears there. Anti-Arctos, no bears, is how Antarctica got its name. So if you think about Anti-Arcticos, Antarctica, no bears, bears in the top, a good way of helping remember that. Shaina, this has been so much fun. I do want to stress, if people want to learn more about you, your work, you are on all manner of social media. You have a beautiful website, scienceshaina.com, so people can check you out there. And of course, this program is done in conjunction with I Was a Kid. So if people want to see more careers, want to see these beautiful artistic representations of all sorts of ways people can get into STEM careers and see themselves in those careers, iwasakid.com or at iwasakidsteam. So many great social media posts as well for all our classrooms today. Shaina, is there any last message you want to share with us before we wrap up and get our classes to say a big thank you and farewell?
Yeah, I think the way that the youth today are empowered to think about this is the thing that the most gives me hope, because I know that kids today, they want our planet to be really healthy and they want it to stay healthy in the future. So I just love that kids are learning and they're getting involved and they're helping to think about ways to make positive change in the world.
Yeah, I like how many of our programs end now with like "Kids rock." You guys just are the best, and you really are. So thank you so much for being here. Classes on YouTube. Thanks for tuning in, and our live classes. Shaina, it's your first time joining us. So how we wrap up every broadcast, I'm going to bring in all our teacher friends to say a big thank you and goodbye. So Miss Pierce's class, Miss Stack's class, Miss Cottrell, Mr. Wheeler, thank you so much. Have a wonderful day.